Chapter 10, Post-Collection Processing of Survey Data. Introduction. This chapter focuses on survey operations that generally occur after data are collected. These steps have the ultimate goal of facilitating estimates of the target population attribute. One way to describe the post-survey processing steps is to contrast a paper questionnaire survey with one using variants of computer assistance. Paper instruments record the answers of respondents. Since the products of surveys are numbers, when data do not have a numeric form, they must be transformed into numbers, an operation called coding. After all the data are in numeric form, then they are entered in some way into an electronic file. For much of the data that are already in numeric form, there may be a restricted set of numbers allowed. Some answers should have logical relationships to others, an operation called edit checks. When there is an item with missing data, researchers may choose to place an estimated answer into the item's data field, an operation called imputation. Some designs require the use of adjustments, weights, for statistical estimation of the target population, and these are constructed after the data are collected, an operation called weight construction. Initial estimations of precision of survey statistics are often conducted soon after data collection in order to assess the quality of the survey estimates, an operation called variance estimation. Although some of these operations can begin as soon as a few questionnaires are returned, they generally are completed only after all the questionnaires are received and data collection operations have ended. This chapter describes 6 different activities that might occur after data collection. Coding, which is the process of turning word answers into numeric answers. Data entry, which is the process of entering numeric data into files. Editing, which is the examination of recorded answers to detect errors and inconsistencies. Imputation, which is the repair of item missing data by placing an answer in a data field. Weighting, the adjustment of computations of survey statistics to counteract harmful effects of non-coverage, non-response, or unequal probabilities of selection into the sample. And lastly, sample variance estimation, which is the computation of estimates of the instability of survey statistics. It's from any statistical errors that are measurable under the design. So section 2 is coding. Coding is the translation of non-numeric material into numeric data. Coding of text material is crucial for the ability to analyze statistically the results of surveys, but the act of coding itself can produce statistical errors. This can have noticeable effects on survey statistics. It is important to note that not all non-numeric data collected in surveys are words. They might be visual images, sounds, or samples of physical materials that need to be described numerically. So the practical issues of coding. Coding is both an act of translation and an act of summarization. Coding is both an act of like all translations, entities in one framework are mapped onto another framework. When the two frameworks are compatible, the mapping can be effortless. When the frameworks are mismatched, the translation task can be complex and subject to error. Coding summarizes data by combining many individual answers into one code category. To be useful, codes must have the following attributes. It must be a unique number used later for statistical computing. It must be a text label designed to describe all the answers assigned to the category. It should have a total exhaustive treatment of answers, mutual exclusivity, and a number of unique categories that fit the purposes of the analyst. For surveys with scientific purposes, each of the code categories should link to different parts of key hypotheses. The total number of code categories to use must be specified. The number of codes must be driven by the intended uses of the variable. Several coding structures can be used for the same measure. One of them is a standard occupation classification. The other is a classification of socioeconomic group. No matter how comprehensive a coding structure might appear to be prior to use, it is typical that at least a few responses cannot be easily assigned to a code. To reduce the occurrence of responses that do not fit pre-structured codes, it is common to take a set of responses and use responses from that set to test and refine a coding structure. The theoretical issues in coding activities. The basic act of coding requires the decision about whether two verbal representations are equivalent. Coding accuracy can arise when the choice of the code category by the coder is exactly what was intended by the respondent. One challenge to this comes from the fact that the coder does not see what the respondent intends, but only words written down by the interviewer. Field coding, an intermediate design. Field coding is the process by which the respondent is presented with an open question for which they form the answer, but the interviewer is asked to code the verbal answer into a numeric category. Field coding thus combines verbal data collection with coding. The standard classification systems. This section describes two commonly used classification systems, one for the measurement of occupation, the other for the measurement of industry. The standardization is valued because it permits a comparison across surveys of attributes of commonly defined populations. So the first we're going to be looking at is the Standard Occupational Classification, or the SOC, and it is defined by this. The classification covers all occupations in which work is performed for pay or profit, including work performed in family-operated enterprises by family members who are not directly compensated. It excludes occupations unique to volunteers. Each occupation is assigned to only one occupation at the lowest level of the classification. Occupations are classified based upon work performed, skills, education, training, and credentials. Supervisors of professional and technical workers usually have a background similar to the workers they supervise and are therefore classified with the workers they supervise. Likewise, team leaders, lead workers, and supervisors of production, sales, and service workers who spend at least 20% of the time performing work similar to the workers they supervise are classified with the workers they supervise. The first-line managers and supervisors of production, service, and sales workers who spend more than 80% of their time performing supervisory activities are classified separately in the appropriate supervisor category, since their work activities are distinct from those of the workers they supervise. First-line managers are generally found in smaller establishments where they perform both supervisory and management functions such as accounting, marketing, and personnel work. Apprentices and trainees should be classified with the occupations for which they are being trained, whereas helpers and aides should be classified separately. If an occupation is not included as distinct detailed occupation in the structure, it is classified in the appropriate residual occupation. Residual occupations contain all occupations within a major, minor, or broad group that are not classified separately. When workers may be classified in more than one occupation, they should be classified in the occupation that requires the highest level of skill. If there is no measurable difference in skill requirements, workers are included in the occupation in which they spend the most time. Lastly, data collection and reporting agencies should classify workers at the most detailed level possible. Different agencies may use different levels of aggregation depending on their ability to collect data and the requirements of users. The second classification system is the North American Industry Classification System, or the NAICS, and it has two lists. The first, the existing classification missed many new business types. It did not reflect the economy of the United States. And secondly, the adoption of the North American Free Trade Agreement underscored the need for comparable industrial production statistics across Canada, Mexico, and the United States. There are other common coding systems. There are many other classification frameworks that are important in different substantive areas. Several of the coding schemes are used in the health field for diagnostic guidance to physicians, for administration of healthcare finance systems, and for epidemiological statistics. There are also a variety of coding and classification frameworks for geographic entities. The quality indicators in coding. Processing errors can arise at the coding step when coding structures are poorly conceptualized and/or their implementation is not uniformly executed. We discussed two kinds of quality impacts. A, which is the weaknesses in the coding structure, and B, the coder variance. So the weaknesses in the coding structure. That's when a code category combines two responses that are non-equivalent for the purposes of the analyst. Consistent and systematic errors can arise. And coder variance. Most of the attention in survey methodology to the quality of coding examines the increased variation in survey estimates because of variation in coding decisions made among the human coders. Coder variance is a component of the overall variance of a survey statistic arising from different patterns of use of code structures by different coders. The perspective is that individual coders vary in their use of the same coding structure, their tendency to use a given code category, their interpretation of certain response words as cues for a given code category, and their tendency to use residual code. In a qualitative study of interviewers, administering the industry and occupation coding have some developed various recommendations to improve the quality of the coding. First, train interviewers to filter as little of the response as possible. Second, train interviewers on the importance of obtaining an occupation name. Third, give interviewers probes to use when listing multiple activities. Fourth, train interviewers as coders. And fifth, provide interviewers with a reference document to assist in probing. So, the summary of coding. The use of coding of text material to numeric data has declined as an unanticipated consequence of increased use of computer assistance in data collection. Coding structures implicitly or explicitly reflect a conceptual framework for the interpretation of responses to survey questions. To be useful to the analyst, the code structure should separate those responses anticipated to be distinctive for their particular statistical purposes. Hence, sometimes different code structures are used on a single question, producing more than one analytic variable. Through variation in the application of a given code structure, coders can increase the instability of survey estimates. Well-trained coders appear to generate relatively smaller effects than those that the interviewers exhibit. However, since coder workloads are generally much higher than interviewer workloads, large increases in standard errors could sometimes arise from coders. Entering numeric data into files. The term data capture is often used to describe the process of entering numeric data into electronic files. In practice, the nature of data capture is heavily dependent on mode of data collection. In most computer-assisted surveys, either the interviewer or the respondent conducts the step. Section 4. Editing. Editing is the inspection and the alteration of collected data prior to statistical analysis. The editing may involve examination of data from a single measure or a set of measures. The goal of editing is to verify that the data have properties intended in the original measurement. The term editing generally includes the alteration of data recorded by the interviewer or respondent to improve the quality of the data. Some uses of the term editing also include coding and imputation, the placement of a number into a field where the data were missing. Editing is accomplished through different kinds of checks. Among those most frequently conducted are range edits, ratio edits, comparisons to historical data, balance edits, checks of highest and lowest values in the dataset or other detection of impossible outliers, and consistency edits. The amount of editing that is used on a survey is a function of how much factual data are collected, whether the sample was drawn using a sampling frame with rich information on it, and whether there exists longitudinal data on the case. Editing, if not well organized, can lead to near endless changes in the data, with the threat that the quality can actually be reduced. In an important contribution, Pelleggi and Holt invented a system of editing that integrates editing and imputation and has a fixed set of steps, replicable given a set of editing rules. The technique begins with 3 assertions. The first is editing should change the smallest number of data fields necessary to pass all the edit checks applied to the data. The second, editing changes should seek to maintain the marginal and joint frequencies of data whenever possible. And third, imputation rules should be deductible from editing rules. Section 5. Weighting. There are 4 different types of weighting that are prevalent in complex surveys. Weighting is a first-stage ratio adjustment, weighting for differential selection probabilities, weighting to adjust for unit non-response, and the post-stratification weighting for sampling variance reduction, and also undercoverage and unit non-response. So firstly is the weighting with a first-stage ratio adjustment. In stratified multi-stage designs, primary selection units, or PSUs, are sampled with probabilities proportionate to some size measure. A simple estimate of the population size in the stratum based on the one selected PSU is the estimated stratum population total, which is equal to the population total in selected PSU over the probability of selecting PSU. An estimate that has lower sampling variance is the first stage ratio adjusted total, which weights all cases in the chosen PSU by W subscript n, which is equal to the first stage ratio adjustment weight, which is equal to the stratum population total frame over the population total for selected PSU over the probability of selecting PSU. Weighting for differential selection for probabilities. That's when the selection weight is y subscript w bar is equal to the summation from I equals 1 to n of w subscript 1 to y subscript 1 over summation from I equals 1 to n of w subscript I2, and that can be found here. Next is the weighting to adjust for unit non-response. To compensate for overrepresentation, an assumption is made in survey non-response weighting that generates the same kind of weighting adjustments discussed for unequal probabilities of selection. If one is willing to assume that within subgroups the respondents are a random sample of all sample persons, then the response data in the group represents a sampling rate. This assumption is referred to as the missing at random assumption and is the basis for much non-response adjusted weights. The inverse of the response rate can thus be used as a weight to restore the respondent distribution to the original sample distribution. Post-stratification weighting. A final weighting procedure applied to many surveys is post-stratification. Post-stratification uses case weights to assure that sample totals equal some external total based on the target population. For statistical efficiency as well as for appearance reasons, it would be helpful if the sums of weights for each gender followed this outside distribution. This can be achieved by a further adjustment to the non-response adjusted weights. So, putting all the weights together. Finally, to obtain a final weight that can incorporate the first stage ratio adjustment, the unequal probability of selection adjustment, the non-response adjustment, and post-stratification, a final product of all four weights is assigned to each class. This final weight combines the four different weights should appear on each respondent data record as a variable to be used in the analysis of the data. Analysts could use weights in some analysts and not others. Analysts could use weights in some analyses and not in others. There may then be inconsistencies between analyses that are difficult to explain or interpret. So the next section is the imputation for item missing data. Imputation is the placement of one or more estimated answers into a field of data record that previously had no data or had incorrect or implausible data. There are a large number of imputation procedures that have been devised to compensate for missing values. Perhaps the simplest method is to replace the missing values for a particular variable by the mean of the item respondent values, say y bar, for that variable. The mean value imputation has several disadvantages. One is that if there are many missing values in the imputed data set, there is a spike in the distribution of the variable at the mean value. The distribution of values in the imputed data is distorted. This approach of imputing within subgroups and adding a randomly generated residual can be thought of in terms of regression prediction for the missing value. Regression imputation requires that all values used as predictors are themselves present for the imputation of a given dependent variable. Regression imputation may require the variables be imputed in sequence so that predictors in a model have imputed values themselves. The regression method has a variety of valuable properties, but large-scale imputation processes often utilize a method developed decades ago, the sequential hot deck procedure. There are a number of other imputation methods that are used in practice, but it is beyond the scope of this volume to consider them, like multiple imputation, which creates multiple imputed data sets, each one based on a different realization of an imputed model for each item impute. Next, we will view the sampling variance estimation for complex samples. Stratification, multi-stage sample selection, weights, and imputed values are features of survey data that require non-standard procedures to estimate variances correctly. Survey data sets based on stratified multi-stage samples with weights designed to compensate for unequal probabilities of selection or non-response, are sometimes referred to as complex survey data. The Taylor series approximation is a commonly used tool in statistics for handling variance estimation for statistics that are not simple additions of sample values. Taylor series estimation is perhaps the most common approach to estimating the sampling variance for means and proportions in complex sample designs, mainly because the currently most popular software packages utilize this approach. We can view the Taylor series right here. The balanced repeated and jackknife repeated methods take an entirely different approach. Rather than attempting to find an analytical solution to the problem of estimating the sampling variance of a statistic, they rely on repeated subsampling. The estimate computed from the total sample is used instead. The difference between the balanced and jackknife procedures is in how the subsamples are selected. The balanced repeated replication procedure typically identifies a half-sample replicate, selecting half the cases or half the clusters or some other half-sampling method. The jackknife repeated replication procedure is sometimes called a dropout procedure. It drops a case or a cluster from the dataset to obtain each successive subsample. Next is survey data documentation and metadata. Rarely is a survey dataset constructed for a single analyst. Rarely is analysis on a survey dataset done once, immediately after the data collection, and then never again. Instead, survey data are often analyzed and reanalyzed by many people over many years. Metadata is a term that describes all the information that is required by any potential user to effectively gain knowledge from the survey data. If one places no bounds on who the user of the data might be, the ability to define what metadata is required is equally boundless. The common types of metadata that are required is first, definitional, where describing target population, sampling frames, question wording, and coding terminology. Second is procedural, where we're describing protocols for training interviewers, developing the frame, selecting respondents, and collecting the data. Third is operational, where we're containing evaluations of the procedures like item missing data rates, edit failure rates, average length of interviews, and number of cases completed per interviewer. And lastly, systems, which is related to dataset format, file location, retrieval protocol, definitions of data records fields, and type of sample element asked about the data item. Codebooks are key tools for the data analyst to make the bridge between the data collection protocol and the individual data items themselves. With the ability to move from the paper codebooks to electronic survey documentation, the world of metadata has become greatly elaborated in the last few years. So now we get to the summary of the post-survey processing. So we learned that survey data are generally not ready for immediate analysis after they're collected. Editing is a process of cleaning data and removing obvious mistakes. Coding, the transformation of text data into numeric data, requires the researcher to invent a code structure that reflects the intended analytic use of the data. Differential weighting of data records in statistical analysis attempts to reflect unequal probabilities of selection into the sample, adjust for omissions in the sampling frame, adjust for omissions from non-responsive sample persons, and improve the precision of estimates by using information about the target population. Imputation is a process of replacing missing data with values later used in statistical estimation. Sampling variance estimation from survey data sets allows the researcher to reflect all the properties of the design that yield measurable sources of variable error. And lastly, survey documentation and metadata need careful consideration at the point of survey design and are vital products of a survey and so that the data will be useful.